Now I'm adding squares together. So this is 1 squared plus 2 squared plus 3 squared. N squared is n times n plus 1 times 2n plus 1.
N.
Ooh, not n to the n. Yeah. N squared over 6. So last time we had divided by 2 and we needed 2 of them to go together. This time we have it divided by 6, so I actually made 6 of them. And this formula suggests that we ought to be able to fit 6 of these together to make a box whose side lengths are n times n plus 1, n plus 1, and 2n plus 1. Now n is 3 here, so our box should be 3 by 4 by 7.
Well, if this works out, we should just be able to make a box out of these, and this should be the parameters.
Yep, that's right. So why don't you see, but before you start really digging into it, are we okay on the camera?
Yeah.
There?
So maybe if we need to
You line it up like that.
line it up like that, and if we, yeah, that would work. We put it.
Except that.
But remember, we don't necessarily need 3 to make half a box. We just need all 6 to make a full box. So maybe if we made another one of these.
We need it to be the mirror image of this, because otherwise it wouldn't lock in properly.
Yeah, that's it. I'll rotate it over.
So this should fit.
So-
No, actually.
Yeah, it should.
Yeah.
No, wait.
No, we made this. I think we made the same shape.
So
we need to make a mirror image.
how about if we
We need to maybe align it.
maybe if we put that on there just to guide us.
Okay.
Here, I'll hold the bottom part of it together.
Does that work?
Yes, it does. So here is our. See, is it 3 by 4?
3 by 4
And
by
7.
2, 4, 6, 7.
3 by 4 by 7.
Cool.
I'm going to try to lay it down because we know it's 3 high, so you can see hopefully on camera that that's 3 high.
4 and 7.
So now you have, I mean, this isn't a proof in general, but you can see that the formula suggests adding up squares gives us a box,
Yep.
and that's what we've done.
Oh, adding up cubes give us a 4-dimensional box.
Oh, well, that is a good question. So I took squares here and made the squares 3-dimensional, right, using snap cubes.
Yeah.
So the first thing we would need would be
Cubes.
To make them 4-dimensional.
4-dimensional cubes. Where did I put those? I put them somewhere. I think I moved them in time. I believe I had them tomorrow. But let's see. So oops, sorry for kicking the camera. The formula is 1 cubed plus 2 cubed plus 3 cubed. Actually, you'll see if you can see the pattern. So with 1, when I add up 1, I just get 1. 1 cubed plus 2 cubed is
That's 9.
9. 1 cubed plus 2 cubed plus 3 cubed. So what's 9 plus 27?
36.
36. Plus 4 cubed would be 64. I'd get 100. Do you notice anything about those numbers?
Well, you're going 1 squared, 3 squared, 6 squared, 10 squared.
1
those are-
squared, 3 squared, 6 squared,
So
10 squared.
that's what you get when you add 1 plus 2. These numbers. You get 1 plus 2, 1 plus 2 plus 3, 1 plus 2 plus 3 plus 4.
Yeah. So the amazing thing is 1 cubed plus 2 cubed up to n cubed equals 1 plus 2 plus 3 up to n squared.
Cool.
Yeah, it's actually pretty cool. But you're right. This made a square, and so now we have two-dimensional objects. So maybe a 4-dimensional object, and we're summing up cubes. to maybe make a four-dimensional object. So maybe you're right. Maybe your intuition is right, although a little harder to think about.
Yeah.
The other thing I just wanted to say about these shapes that we're playing with here, what do these shapes look like to you?
Like, sort of like pyramids.
Yeah, they sort of look like pyramids. The problem is, the reason they're not pyramids is because they have sort of jump steps,
Yeah.
right? But I could actually make pyramids. Now, these are made, we 3D printed these are made with layers, so they do have little jump steps too, but they're just not as
Big as those.
big. So what do you think 3 of these should be able to do?
Well, they should make maybe half of our box.
Right.
But they make a cube, I believe.
Fit them together, right? There, here's the cube.
So they make something that looks like a cube.
There we go.
So instead of getting n times n plus 1 times 2n plus 1 over 6, I got something that looked like a cube.
Yeah.
When I put 3 of them together. So I multiply this by 3, I get this over 2.
I mean, maybe because n here is so large, like the layers are so tiny,
Uh-huh.
that it's starting to look like n cubed here.
Right, it's starting to look like the plus 1s don't matter
Yeah.
because there's so many n's. So the top looks like 2n cubed divided by 2. I get n cubed. And so this idea isn't just nonsense, actually. This idea is actually sort of a foundational idea in calculus, that you can approximate things better and better, even using things that don't look like very good approximations right in the beginning. So anyway, so that's it. I just wanted to spend a little bit of time today talking about some of these connections between arithmetic and geometry, because they're very cool. And maybe we'll find a way to explore that four-dimensional connection. That would be really fun.
Yeah.
All right. Good job, guys.